they observed that when mercury was exposed to extremely low temperature, its surgical resistance suddenly got out to zero. The discovery was very important and earned Nobel Prize to resistance. For many years, superconductivity could only be achieved at very low temperature, close to cosmic zero. However, in 1980s, scientists discovered high temperature superconductors, which work at completely high temperatures, making them more practical. The next topic was type of superconductors. Superconductor mainly classified into two ways: type 1 and type 2. Type 1 are pure metals like mercury and lead. They lost superconductivity when the magnetic field is applied. Type 1 superconductors are low temperature superconductors. They need extremely cold conditions, which is present. And second one is type 2 superconductors. They are alloy or compound. They can work under strong magnetic fields, so they are more useful in real world applications. Okay, very good. Superconductors are classified into two categories: type 1 and then type 2. Okay. The next one, working principle. The working principle of superconductor is explained by the SNS theory. According to this theory, the electrons. Okay, very good. Tell me. The electrons in the superconductor form gas, which is known as supermass. In this, the electron collide with the atoms. This energy causes resistance. However, the superconductor, which has a group mass, move together without scattering. Then there is no resistance. Then the electric current flows freely without electric energy loss. So now we saw the working of the factors. Let's see about the
Okay, very good. Okay. So now we start using about their applications of superconductor. So used in the medical imaging and transport research and power systems. So superconductors have many important applications. They are widely used in MRI machines in hospitals, which helps the doctors to use inside the human bodies. They are also used in the mainly trains, where the trains floats above the tracks using the magnetic limitations, reduces the frictions and allowing very high speeds. Superconductors are also used in the powerful research equipments like Hadron's cloner, which scientists study the particles. So additionally, they can be used in the power transmission lines to reduce the energy loss. Okay, very good.
So let's just discuss the challenges and future scopes. So it mainly issues the cooling, cost, etc. Research is ongoing for low temperature superconductors. So the main is it also have advantages, but superconductors also have some more challenges. Most superconductors require extremely low temperatures, which make them expensive and difficult to maintain. The cooling system needed, such as liquid helium, and the cost complex. Another challenge is that superconducting materials can be fragile and difficult to manufacture. However, scientists are working on developing room temperature superconductors, which could completely change the economy. They could revolutionize energy systems, transportation, and electronics. So, conclusion: superconductors are powerful technology with great potential for the future. Thank you so much.
Okay, very good. Yes. How to classify whether the conductor is semiconductor and superconductors? Based on the value. What is the value? Based on resistance value. Okay.